As we move on and talk about electric current, we need to understand it goes deeper than this because the current that flows through a circuit, which we'll be getting to circuits next week, that's the next topic we'll get to. The current that flows through a circuit, it depends on a lot of things, right? This guy, Georg Ohm, lived from 1789 to 1854 in Germany, and he's the one that discovered the relationships and what determines current in a circuit. So as we talk about Ohm's law, which was named for him, what Ohm kind of hit upon was this idea of resistance. Electrical resistance is simply defined as hindrance to the flow of charge. We understand that electrons flow spontaneously from negative to positive, just like water can flow. And just like water flow, there can be things that resist that flow, that hinder that flow, that make it slow down. So electrons do the same thing. So there are a lot of things that hinder the flow of charge, and that's like any electrical devices, like a light bulb, a radio, a heater. Anytime we run electrons through a device and they do work to convert their electrical energy to some other form, that slows down the current and that imparts resistance. Also, a resistor does that, right? So these are our devices that impart resistance. Your phone has lots of different devices in it that impart resistance to the current, as well as these little devices here, which are simple resistors. They don't really do anything. They don't create light, heat, anything like that, but they simply hinder the flow of charge. They impart resistance. So we can measure the resistance. Different devices and different resistors impart a different amount of resistance, right? Just like we can put different amounts of things in a creek, and that can impart different amounts of resistance to the flow. Resistance is measured in ohms, right? And that's what this letter up here, this is actually a Greek letter. It looks like an O that we've kind of chopped the bottom off of, or it looks like a horseshoe maybe. It's a Greek letter called ohm, and it's named after Georg Ohm. We honored him with that unit, and Ohm's law, the equation that's named after him, is I equals V over R. So we've already talked about V, I think. No, we haven't. V is the variable for voltage, which makes total sense. And V is also the unit for voltage. Voltage is measured in volts. Very simple. I, we've already talked about. I is current. Current is measured in amps. And then R is our new variable here. R is the variable for resistance. And the unit for resistance, we measure resistance in ohms. And the letter is that omega. It's a Greek letter called omega. Sorry, I think I said it was ohm before. We call it ohms, but we use a Greek letter omega to indicate it. Now, there's a couple other forms of Ohm's law. If we just do a simple algebraic solving by multiplying by R on both sides of this, that will solve Ohm's law for voltage. You might want to use this sometimes. It's the same equation. It's still Ohm's law. It's just Ohm's law for voltage. V equals I times R. And we can still further solve that for resistance, and we get R equals V over I. But these two are the ones that we use most often. It's the ones that you'll see most often. So as far as Ohm's law is concerned, it's really important that you know that you should be already be able to see this, but Ohm's law says that current, which is I, current in a circuit is dependent on two things, and those two things are the two things in this equation. Voltage is one, and voltage is directly related to current. And remember, another word for voltage is potential difference. So this is a direct relationship. That means the greater the voltage, the greater the current. If we have a bigger voltage in a current, a bigger potential difference, that means we're going to have a higher current, a bigger flow of electricity. And the other thing is resistance. Resistance is inversely related to current. The higher the resistance, the lower the current. The lower the resistance, the higher the current. And so I've got a couple of pictures here that help us to see, practically speaking, what this is about. This picture on the top left might be kind of funny looking, but volts, that's voltage. Ohms is the unit for resistance, that's our resistance. And then amps is the unit for current. And these kids over here are saying what this picture is saying. Voltage supplies the push. So voltage is directly related to a current. Voltage is the reason why current happens. It's the reason why current flows. Voltage, remember, is that difference in charge, the difference in energy from the positive to the negative side. That's the whole reason why electric charge flows. So the voltage is what's supplying the push. The greater the voltage, the greater the gusto, so to speak, that the electrons want to go to the other side. Whereas resistance opposes that push. Resistance is inversely related to the current, right? So we have this resistance guy up here that's got a if you can imagine a rope around a hose, voltage is pushing the amp guy through, but ohms is cutting it off, indicating resistance to flow. The higher the resistance, the lower the flow. And the current is the result of both of these two things combined, the result of voltage and resistance. So this is how resistance works. A few simple problems, simple equations. What's the resistance of a circuit with a 9-volt battery and a 3 amp current, where this is our voltage, this is our current. Remember, current is I equals V over R. So for I, we're going to substitute 3. For V, we're going to substitute 9. Now, when we go to solve this, remember, a lot of algebra errors happen. A lot of people want to just automatically divide or multiply here. The best thing for you to do if you're solving for the variable in the denominator is to first get that variable out of the denominator by multiplying by it on both sides. So the first thing we're going to do is multiply by r on both sides to get it out of the denominator on the right. It puts it on the left side. We end up with 3r equals 9. And now it's a lot easier to see that what we need to do is divide by 3. 9 divided by 3 gives us 3 ohms of resistance. 9-volt battery, 3 amps of current, 3 ohms of resistance. Fairly simple and straightforward problem. All right, I want you to try this one now. Pause the video and see if you can do this one on your own. All right, let's look and see if you got it right. What's the current in a circuit consisting of one 9-volt battery and one 10-ohm light bulb? 9 volts, that's our voltage. 10 ohms is resistance. We want to know current, which is I. Super, I was almost like insulting that I gave this to you almost. 9 divided by 10. That's all we got to do. V is 9. R is 10. We know it's R because ohms is our unit for R. 9 divided by 10 is 0.9 amps. That's our current. All right.